Hello friends, today we are going to derive the second equation of motion graphically. So what is second equation of motion? S is equal to ut plus half at square, where symbols have their usual meaning. S is the magnitude of displacement, that's distance. U is initial velocity, T is time, A is acceleration. Since this S gives me the position of the object at time t, this is also referred as position time relation. This is also referred to as position time relation. So we are going to derive position time relation. Now children, you know that we are deriving it graphically. So let's draw the graph. The graph we have to draw a VT graph. Okay, we have to draw a VT graph. Now you know it's a VT graph. We have to take some consideration. Our consideration is that an object was at point A. An object was at point A and it was moving with some initial velocity. That initial velocity is u. It's moving with this much initial velocity u, because this graph represents y-axis as velocity, and this is your initial position O. Okay, so AO is u. Then it accelerates uniformly. Okay, it accelerates uniformly, uniform acceleration, okay, which is represented by small a, and it reaches point B, and at point B its velocity became, final velocity became V. Now this is the graph. We will do some simple constructions for our derivation. That construction is draw a line perpendicular from B on the time axis. Mark this as C. What I have drawn? A line perpendicular to the time axis, okay, and I have marked it out as C. And again one more construction, a line parallel to the time axis from A. From A, a line, this is your time axis, a line parallel to the time axis from A. Mark this as D. Okay, now let us come back to our derivation part. Our derivation starts from, it's always important to understand where the derivation starts from. Our derivation starts from the fact that it's a VT graph, and area under VT graph, you know, area under VT graph, it gives us what? It gives us the displacement magnitude, that is the distance traveled. So we'll write area under VT graph gives S, distance traveled, or the magnitude of displacement. So that means S is equal to area. Now this is your area under the graph. Okay, this is your area under the graph. What you have to do in this is, you have to divide this area into two parts. One is the rectangle area, this rectangle, and another is this triangle. Okay, so we'll just take area of rectangle. Name the rectangle ADCO plus area of triangle. Name the triangle now. What is triangle? ABD. Now just substitute the formula. Area of rectangle is length into width. So this is your length, this is your width. It will be AO multiplied by OC plus triangle area. What is the formula for area for triangle? Half base into height. What is the base of this triangle? AD into height. What is the height of the triangle? BD. Okay. Now these AOOC, AD, BD we don't want. What do we want? UVAT. So wherever possible we will substitute the direct symbols if it is possible. Coming back to the graph, CAO. What is AO? AO is equal to U into OC. What's OC? OC is equal to time taken plus half AD. What's AD? AD is not equal to something, but AD is equal to OC, and OC is equal to time. See here, AD is equal to OC and OC is equal to time. So time, BD is not a direct symbol over here, so we'll leave BD as such. Mark this as equation number 1. So if you see, half part is already done. UT you have got, half you have got, T you have got. Instead of BT, something should come over here. Now BD. We'll do the BD derivation over here. See from the graph BD. You have to bring A in this equation. A is acceleration. Now acceleration, how to bring? See, this is a VT graph. You know that slope of a VT graph What does it gives? Slope of a VT graph. Slope of a VT graph gives acceleration. Okay, slope of a VT graph, it gives acceleration. We have learned that. That means acceleration is equal to slope. And what is the slope formula? Vertical distance by horizontal distance. See here, this is your graph AB. What's the vertical distance? BD. What's the horizontal distance? AD. Okay. Now A is equal to BD by AD. AD is equal to OC. Just now we did AD is equal to OC, which is time taken. Simple rearrangement, you will get BD is equal to AT. Mark this as equation number 1. You have got your BD. Substitute this value of BD in equation number 1. So write substituting value of BD from equation number 2 to equation number 1. Just substitute it. What will you get? You will get S is equal to UT plus half into T. What should I write BD as? See here, AT. AT. And here you get your relation. S is equal to UT plus half AT square. This is second equation of motion. We have derived second equation of motion, also known as position time relation. S is equal to UT plus half AT square. Hope you understood it. Thank you.